Welcome to Sundar's lecture, and this is lecture number 8. We have seen voltage division rule and current division rule in the last class. And what is voltage division rule? Actually, if you want to find what is the voltage across this resistor in a series circuit, that should be noted down. In a series circuit, if you want to find what is the voltage across a resistor, then what you can do? You just multiply this total voltage into this particular resistor divided by total resistor. You see, that is the formula. That is what we have written as the definition here, right? So next, current division rule, little bit different from the voltage division rule. That's all. If you want to find what is the current in a parallel circuit, that means parallelly connected resistor circuit, then current through this resistor will be equal to total current. That you have to understand. Total current multiplied by you see I1, I am telling for I1, total current, that is IT, multiplied by opposite resistor R2 divided by total resistor R1 plus R2. This is what we have seen in the last class. Right. Now what we do, we will take examples, problems, numerical problems. And we try to apply this voltage division rule and current division rule to get the values, right? So we will take a problem, right? So we have taken the problem. So you see, it is a series circuit. You have to understand, because we can apply voltage division rule only in the series circuit, not in the parallel circuit, right? So you see, this is the series circuit, voltage given, that is 60 volt, and every resistors are given. They are asking you to find the voltage across each resistor, which means what you do by yourself now. What is that? This, let us we assume this is V1, voltage across this resistor is V1, and voltage across this resistor is V2, and voltage across this resistor is V3, right? We have assumed. They have not given, but they have asked you to find what is the voltage across each resistor. And we know the formula, right? What is the formula to find voltage across a resistor in a series circuit by voltage division rule? You try to understand one thing. You never uh, mug up any formulas. Try to understand the concepts of the formulas, which means let me write the formula now. See how I am writing the formula. You try to understand that. So V1, I need to find V1, voltage across resistor 1. That means voltage across this resistor means what you have to do, you have to multiply total voltage, which means I will write it as a formula here, total V into this resistor value, that means R1 divided by total resistor, R1 plus R2 plus R3. That's all. So you see, this is R1 plus R2 plus R3. You have to write the formulas like this. You don't mug up the formulas. It is not at all necessary. Try to understand the concept. The voltage across this resistor, which is nothing but total voltage multiplied by this resistor divided by, that means ratio of that particular resistor divided by total resistor. If you understand like this, you can easily remember the formulas. That's all, right? So now you substitute here. So V, what is V? We know that is 60 into, what is this R1? That is 10 divided by, and what is the R1 again? 10 plus 20 plus 30, right? This one we know, which means if you further simplify this, we will get 60 into 10 divided by, what is this? 30 plus 30, it will be 60, right? So this 60 will be cancelled out. So what you will get? You will get 10 volt, which means final V1, which is equal to 10 volt. That's all. V1 which is equal to 10 volt. So this is the final answer. Now we need to find what is V2. So what is V2? How will you write V2? Which means total voltage. Again, formula will be like this: total voltage into that particular resistor R2, that means V2, we are finding V2, this resistor divided by total resistor. That's all. So what you will get? R2 divided by R1 plus R2 plus R3. And this we know now. How? What is this one? This is 60 that we know, and this is 20 divided by what is this value? What is this value? What is this total value? That is 60. That is 60. So you directly put here. So what you will get? Obviously these two will be cancelled out. Always these two will be cancelled out because formula is like that, right? So formula is like that. Always here also it will be cancelled out. Here also it will be cancelled out. Anyhow, what is the V2? V2 will be equal to 20 volt. That's all. And you can say that what is V3? V3 will be 30. That you have to understand, right? V3, which is equal to total voltage into R3 divided by R1 plus R2 plus R3, right? So what you will get? This is 60 into R3 is 30 divided by what is this total voltage? What is this total voltage? That is what we are finding it out right away in the previous V1 and V2 as well. So what is this? This will be 60. So these two will be cancelled out, and again V3 will be equal to 30 volt. And you try to understand another one concept. You are giving total of 60 voltage and it is divided as three parts, that is V1, V2 and V3. And if you want to find what is total V using this, total V should be what? V1 plus V2 plus V3. This should be done. This should be satisfied, right? Then what is the value? What is V? We need to find. What is V1? 10. This is 20. And this is what we have found it as 30. If you add all these, you will get 60 volt. You have to get, right? So this is how you need to find what is the voltage across the resistor in a series circuit. See, what is the shortcut we have done here? We have not found the current. That is the point of getting this voltage division rule and all. But you are finding out current where? You see, V divided by R1 plus R2 plus R3 is what actually the total current. Total current into particular resistor. That I'm not going very deep into that. Anyhow, we are just solving the problems by the given values. That's all, right? That is how we are applying this. Okay, fine. Now what we do, we will take another problem to solve the current division rule. We try to apply the current division rule. Okay, see, this is the problem given, which means it is a parallel circuit. You can see that. How I am telling this is parallel circuit? Because these resistors are connected parallel to the voltage source. Now what they are asking you to find the current in each resistor, which means we need to find what is I1 and what is I2, right? Now, we have so many methods to solve this because how many loops are there? This is one loop and this is the second loop. So you apply KVL, solve the both equations, you will get I1 and I2. No problem. But we are trying to apply the current division rule here. So what is current division rule? What is the formula for current division rule? You see, if I want to find what is I1, I1, right? If I want to find what is I1, what I have to do? This current, I have to get the total current IT into what? Opposite resistor value here. It is not like voltage division rule. This is slightly different from the voltage division rule. Here it is opposite resistor divided by total resistor. What is total resistor? R1 plus R2. That's all. You will get R1 plus R2. Right? You have to apply like this. Then what is the formula for I2? I2, which means this resistor's current. That is also same thing, but it will be different. What is that? IT, that is total current into opposite resistor. What is the opposite resistor to this R2? That is R1. That is R1, right? So R1 divided by R1 plus R2. One thing you see, we know R1 R2 values, but we don't know what is this IT, right? Here they have given, okay, fine, I have not given the voltage value. Voltage value, let us we take 50. I have not given here 50 volt, right? 50 volt. So we were not given with the IT. Total current is not given in this circuit, right? So you have to find the total current. How will you find the total current? Huh? Let us tell me one thing. That means you see how these two resistors are connected, and this resistor values were not also given, right? So R1 is 10 ohms, R2 is 20 ohms. So these two values are given. Now what you can do, you can just simplify these two, right? This is connected in parallel, so what you do, you bring this as single resistor. We know that, right? We have already seen. So what is the formula to bring these two resistors to a single resistor, which means you need to find the parallel resistor value. That means 1 by Rp will be equal to 1 by R1 plus 1 by R2, right? So what you will get? You will get what? 1 by 10 plus 1 by 20. Huh? So if you find what is the total RP value, so I'm getting it as 6.67 ohms. You simplify this, you will get this. So how I can draw how I can draw this diagram right now? So you see, I can draw this voltage, right? Then I have simplified this to a single resistor, right? Single resistor. So I can write like this. This is plus minus 50 volt. Then what is this resistor? 6.67 ohms. 6.67 ohms. So this is nothing but what? IT. The same IT is there. I have just simplified these two resistors. Now you can find IT, right? How will you find IT? So IT can be written as IT, which is nothing but what? V divided by R. This value. This R value, right? So what is this value? 50 divided by 6.67. That is nothing but IT, right? So what is now? What is IT? So if you simplify this, I am getting it as 7.5 amperes, right? Now we have found what is IT, right? This total current has been found. That is nothing but it is 7.5 amperes. Now we need to find what is this I1 and this I2. That is what we for that we have written the formula, right? So how will you find that? How will you find that? So I1 will be equal to what? IT. IT is what? 75. So, sorry, 7.5. So this is 7.5 into what is R2? R2 is 20 divided by R1 plus R2. So 10 plus 20. So what you will get? If you simplify this, 7.5 into 20 divided by 30, right? So if you simplify this, I will get I1 is equal to, I am getting it as 5 amperes. I am getting it as 5 amperes, right? I am getting it as 5 amperes. Then if I want to find what is I2, I2 will be equal to, this is IT we know that it is 7.5 amperes into, what is this? R1. R1 is nothing but it is 10 ohms divided by 10 plus 20, R1 plus R2. R1 plus R2. So what you will get? 7.5 into 10 divided by 30. So final value will be, if you simplify this, I2 will be equal to 2.5 amperes. 2.5 amperes. That's all. We have found what is I1 and I2 by using the current division rule. And if you want to find what is IT, total IT will be equal to what? I1 plus I2. I1 plus I2. Right? What is I1? What is I1? That is 5 plus what is I2? That is 2.5. If you simplify this, IT will be equal to 7.5 amperes. Right? Okay. So whatever the value we have found here, that means I1 and I2, which is correct. Right. We have applied current division rule and voltage division rule. Okay, fine. Thank you. We will see in the next class.